9.4. Solving quadratic equation in quadratic form. So what does it mean by equations in quadratic form? Because quadratic equations, we know that it is in ax squared plus bx plus c equal to 0. So any equation that can be rewritten as something square, okay, and then the x term in the middle, in that format, then we call it, that equation is quadratic in form. So how do I determine the equations it is in quadratic form or not? So right here, this is what we check. After you rewrite it into descending power, the exponent of the first term, okay, the exponent of the first term is double of the exponent of the second term. If that's the case, then we know that the equation is quadratic in form. So take a look at on the first example. Exponent of the first term is 4. The exponent of the second term is 2. So isn't it the exponent of the first term is double of the second term? Exactly the same thing. If you look at right here, it's square, and then right here is nothing. That means 1. And take a look at on right here, half. Okay, and then fourth. Isn't it 1/4 times 2? That is half. And then right here is negative 2. Here's negative 1. And notice that this is 2/3. 2/3 is basically 2 times 1/3, so double of it. And similarly right here, 1. 1 is basically what? 1/2 times 2, because square root of x is 1/2 exponent. So that's how we figure out this equation is quadratic in form or not. If the equation is quadratic in form, this is the technique that we're gonna use, the substitutions, and then factor it out. So let's take a look at on solving the first equation. So we see that the variable of the first term, the exponent of the first term is double of the second term. So therefore, this is quadratic in form. If it is quadratic in form, this is what we can do. I can say that let u be equal to x to the second power. So therefore, when I take a look at on my equations, x to the fourth power is basically x to the second power minus 11x squared plus 28 equal to x 0. So now what I will do is I will substitute u to make it easier for us to continue. So x squared is u, so it will be u to the second power minus 11 x squared is u, and then plus 28 equal to 0. So this is the trick. This is the main trick. You substituting it so that it looks like the equation that we solved before, and then now we know how to solve it nice and neat. So solving quadratic equation, the very first thing is check can we factor or not, and this is factorable, which is u minus 7 and then u minus 4. Using zero factor property, u minus 7 is equal to 0, u minus 4 is equal to 0. So therefore u is equal to 7 and then u is equal to 4. Now this is not our final answer because the equations, original equations, the variable is x. So therefore I need to solve for x, in which now we substitute back what u is representing. U is basically representing x squared, so I substitute back x squared and then continue solving it. Equal to 7 equal to 4. Now this is square root property is applicable, so I'm going to take the square root on both sides. And don't forget plus or minus sign. So this gives me square root of x squared is equal to plus or minus 7. So therefore x is equal to plus or minus square root of 7. So that's my two solutions. And then continue on the other side, take the square root on both sides, and don't forget plus or minus sign. So this gives me square root of x squared is equal to plus or minus square root of 4. So therefore x is equal to plus or minus 2. Now we have a total of 4 solutions, which is negative square root of 7, negative 2, 2, and square root of 7. And this will be my final answer. And then from now on, all the problems will be same process. Right? We're doing the same process. But on the test, what you need to do is recognize this is quadratic in form or not. Once again, how do we recognize quadratic in form? The exponent of the first term must be double of the exponent of the second term. So now, taking a look at this, the next example, I'm going to let u be equal to x minus 4. So therefore, the first term becomes u squared, and the second term becomes 8 times u plus 15 equal to 0. So now, factor it out. If this is factorable, so it will be u plus 3 and then u plus 5. And using zero factor property, u plus 3 equal to 0. And then u plus 5 equal to 0. So therefore, u is equal to negative 3, u is equal to negative 5. Now, we substitute back what we originally started with. My u is equal to x minus 4. X minus 4. So therefore, when I solve for it, add 4 to both sides, that become x is equal to 1. And then when I solve for on the other equations, add 1 will become negative 1. So which our final answer is negative 1 and 1. Moving on to the next example. So looking at this next equation, x minus 7 square root of x plus 12. This is basically, you can look at it as x to the first power minus 7 x to the 1/2 power plus 12 equal to 0. Remember, square root, cube root, we can rewrite it as a rational exponent. So now I'm going to let u be equal to x to the 1/2 power, which is square root of x. So this gives me u to the second power on the first term, and then the second term will be negative 7 times u. U to the second power minus 7 times u plus 12 is equal to 0. Because x to the first power, you can look at it as x to the 2 times 1/2, right? Or maybe this way is better for you to see. That is basically x to the 1/2 power to the second power. So you can look at it this way. So now, factoring out, it will be u minus 4 and then u minus 3 equal to 0. Using zero factor property, u minus 4 is equal to 0. U minus 3 is equal to 0. Solving for u, so u is equal to 4 and u is equal to 3. Now, substituting back with the original variable, my u is square root of x. My u is square root of x. So therefore, we got square root of x is equal to 4. Square root of x is equal to 3. Solving radical equation, first radical, one radical term must be on one side. We got that already. Now we're going to raise the power the same as index. Since this is square, we're going to raise the power 2 to both sides. Right? Because of square, we're going to raise the power 2 to both sides. So this will become square root of x equal to square equal to 4 square, so therefore x is equal to 16. Now the next one, square root of x squared is equal to 3, so therefore x is equal to 9. So from here we got two solutions, which is 9 and 16. That will be my final answer. Moving on to the next equations. So x to the 2/3 power, x to the 1/3 power. So we're going to rewrite this as x to the 1/3 to the second power, because exponent to exponent we multiply, so 1/3 times 2 is 2/3, and minus 5x to the 1/3 power minus 14 equal to 0. So I'm going to let u be equal to x to the 1/3 power. By this time, probably you noticed that already, we always let u be equal to our middle terms, right? The variable of the middle term. So that way it will nice and neatly it come out, which is u squared for the first term, and then negative 5 times u on the second term. So u squared minus 5u minus 14 equal to 0. Factor this, which will become u minus 7, and then u plus 2 equal to 0. Using zero factor property, u minus 7 is equal to 0, u plus 2 equal to 0. Solving for u, so u will be equal to 7, and then u will be equal to negative 2. Now, for each equation, we need to substitute back with our original equations, right? Variable. And remember that x to the 1/3 power, that is basically what? Cube root of x. So therefore, my u is cube root of x, right, equal to 7. And cube root of x is equal to negative 2. So solving radical equations, cube root, the radical term is isolated already, so therefore next step is raise the power to both sides. I raise the power to the 3rd power, raise 3rd power, because the index is 3. So therefore this will give me cube root of x to the 3rd power is equal to 7. So x is equal to 343. Then the next equations will be cube root of x to the 3rd power is equal to negative 2. So therefore x is equal to negative 8. So now we got our final answer, negative 8 and 343. That would be final answer. Moving on to the next example. So now you can see that x to the 1/2 power. That is basically, we can rewrite it and then look at it as x to the 1/4 power to the second power, because 1/4 times 2, they give me 1/2, which is double of the double of the exponent of the second term. So 8x to the 1/4 power plus 15 equal to 0. So now, using the substitution, so I will let u be equal to x to the 1/4 power. Remember that 1/4 power is 4th root of x. So substituting u, so the first term will become u squared, and the second term will become 8u. So u squared plus 8u plus 15 equal to 0. Now this is in quadratic equation format. Factoring out, it is factorable, so it will be u plus 3 and then u plus 5. So this will become u plus 3 equal to 0, u plus 5 equal to 0 by using the square zero factor property. Solving for u, so u will be equal to negative 3 and u will be equal to negative 5. And we now substitute our radical, which is u is 4th root of x, right? U is 4th root of x. That is equal to -3 and equal to -5. And remember that if the index is even root, the outcome will be always positive. So therefore, in this case, for the first case, fourth root of x is equal to negative number. That cannot happen, so there is no solution. Similarly, for the second part, fourth root of x is equal to a -5. And remember, even index, the outcome is always positive, so this cannot be equal again. So therefore, my final answer is no solutions for this. Next, I will look at this equation as 8x to the -1 power to the second power, which is -10x to the -1 power plus 3 equal to 0. Now, I'm going to let u be equal to x to the -1 power. Remember, x to the -1 power is equal to 1 over x. So substituting it, it will become, the first term will become 8 times u squared minus 10u plus 3 equal to 0. So factoring this out, this gives me 8 and then 3, so that will become, I want 4u and 2u, and then minus 3, oh, I made a mistake right here. So this should be, my bad, 3 right here and then 1 right here, which is going to be 6 and then 4, that will give me 10. So this will give me 4u minus 3 equal to 0, and then 2u minus 1 equal to 0. And again, factoring part, you can always use the technique that I taught you, before. So continuing this, that will become 4u is equal to 3, and then u is equal to 3 over 4. Now substituting u for 1 over x, right? 1 over x, and this gives me 1 over x is equal to 3 over 4. Cross multiplying, that will become 4 is equal to 3x, so therefore my x is equal to 4 over 3. That's one answer. Similarly, for the second one, solving it for u, add 1 to both sides and divide by 2 to both sides. And substituting back u with 1 over x, and this gives me 1 over x is equal to 1/2. And since this is a proportion type problem, we can use cross multiplying methods. So therefore, I got the second answer is 2. So now my answer is 2 and then 4 over 3. And this concludes the session.